Hi, and welcome to this lesson, which is on metallic bonding. Okay, get the title down and we will move on. So, we've already seen that when we have a metal and a non-metal together, they use ionic bonding to join. A non-metal and a non-metal uses covalent bonding. What about with a metal and a metal? Well, that uses metallic bonding. So what are the typical properties of metals? Well, we can look at the properties of transition metals for that. So they're lustrous, they're hard and strong, they've got a high density, they're malleable, which means that they can be bent into shape, and ductile, which means that they can be pulled out into wires. They're also good conductors of both heat and electricity. They have high melting and boiling points, except for mercury, which is liquid at room temperature. And those properties between them all indicate that there are really strong bonds between the atoms of metals. So what's going on? Well, if we take a sodium atom, we know that to become stable, it needs to lose the one outer electron in its outer shell. If it's bonding with, say, chlorine, it transfers to the chlorine. But where does the lost electron go if it's bonding with a load of sodiums? Where do all the other lost electrons go? Well, what happens is it forms a giant lattice of these positive ions that are left because they've lost their electrons, with the electrons in between them. Okay, so the whole of the shaded area in that diagram represents a cloud of delocalized electrons which are constantly moving around. And they move around the whole structure, just staying close to some of the positive ions, but not any particular one. So the reason they stay close to positive ions, remember, is because electrons are negative, and negative is attracted to positive. Okay, so there are strong metallic bonds, and that's caused by the electrostatic attractive forces between the delocalized electrons and the positive ions. Okay, so key points. Metal atoms form a giant lattice which is similar to ionic compounds. The outermost electrons on each metal are free to move around the structure and form a sea of electrons. Having released the electrons into this sea, the metal atoms are left with a positive charge. They become a positive ion. And those positively charged ions are attracted to the sea of electrons, and the metallic bonding is that holding together. So, why different properties? Well, the materials differ in their properties because each atom transfers its outer electrons to form this sea of electrons with the positive ions in it. But aluminium has 3 outer electrons, magnesium has 2, and sodium only has 1. So that means aluminium is stronger and has a higher electrical conductivity than sodium because it's got stronger metallic bonds. The metallic bonds consist of positively charged metal ions in a sea of delocalized electrons. Aluminium forms aluminium 3 plus ions, whereas sodium only forms sodium plus. Right, so we're going to try and complete this table now. So what I'd like you to do is copy it out and have a go at filling it in. Pause the video while you're doing that, and then when you're done, press play again. Okay, so in ionic compounds, what type of elements are involved? That would be a metal and a non-metal. For covalent substances, that is 2 non-metals. So a non-metal and a non-metal. They can be the same type of non-metal. For metallic substance, it's metal and metal. And again, it can be the same type of metal. What makes the bond in ionic compounds? Well, it's the attraction between a positive ion and a negative ion. And the ions are created by the transfer of electrons from the metal to the non-metal. For covalent substance, the bond is formed by the sharing of a pair of electrons, what we call valence electrons. And for a metallic substance, the bond is caused by the attraction between those positive ions and the sea of delocalized electrons around them. Okay, so the next question is, what structures are produced? For ionic compounds, it's a giant lattice structure that's produced, giant ionic lattice. For covalent substances, it can form 2 different types of things. You can form simple molecules, small molecules, or you can form a giant lattice structure, which is what you have in your diamond and your graphite. And then for metallic substances, again, that's a giant lattice. In this case, we call it a giant metallic lattice. Okay, so the properties. For ionic compounds, they are water-soluble, they're strong, they have high melting points and boiling points, they can dissolve, sorry, I've said that one already, they're good conductors as long as they are either in melted form, so as a liquid, or if they've been dissolved. For covalent substances, it depends on whether they're the simple molecules or the giant lattice. If it's a simple molecule, then they've got low boiling points and melting points, and there are only weak bonds between them. If they're giant lattices, again, we're looking at high melting and boiling points, and they get quite strong substances. For our metallic substances, they're strong, high melting point and boiling point, they're lustrous, they're malleable, they're ductile. They are excellent conductors of both heat and of electricity. Okay, so have a go at the questions that I've put on fronter for you and email me if you have any problems.